Geometry, Chapter 8, Lesson 2, and in this portion of the lesson we're going to be looking at the properties of the 30, 60, 90 triangle. Now, in the 30, 60, 90 triangle, we do have a right triangle, so the side that is opposite that right angle is still going to be called the hypotenuse, because that's always the name of the side that's opposite the 90-degree angle. Now, unlike the 45, 45, 90, where we had both the other angles the same measure, in the 30, 60, 90, we have one angle that's 30 and one angle that is 60. So you have one angle that is larger than the other. And you remember the theorem we talked about where the longer side will be opposite the larger angle. So in this case, because I have two different size angles, the sides of these or legs of this triangle are going to be different lengths, unlike the 45, 45, 90. And again, the smaller the angle, the shorter the side, and the larger the angle, the longer the side. So the side that is opposite the 30-degree angle is going to be called what we call the shorter leg. It's the shorter of the two legs that are not the hypotenuse, because it's opposite the 30-degree angle. And then the side that is opposite the 60 then is going to be known as the longer leg. Alright, so unlike the 45, 45, 90 where both the legs were the same, in this case one of the two legs will be shorter than the other. And that's going to be determined by looking at the angle and looking across from that angle to determine which one is shorter and which one is longer. So when you begin looking at a 30, 60, 90, one of the first things you want to identify is which leg is the longer, which is the shorter, and which is the hypotenuse. Now, both the longer leg and the hypotenuse are related to the shorter leg. You remember the hypotenuse in the 45, 45, 90 was related to the legs of the 45, 45, 90. In that we could multiply the length of the leg times the square root of 2 to quickly calculate the hypotenuse. In the 30, 60, 90, you can calculate the length of the longer leg by relating it to the shorter, and calculate the length of the hypotenuse because it's related to the shorter. But there is no direct relationship between the longer leg and the hypotenuse. So mathematically speaking, and you'll see what I mean later on, given the length of the longer leg and asked to define or to find the length of the hypotenuse, I can't do that directly. It's going to be a two-step process. I'm going to have to determine the length of the leg, and then once I know the length of the shorter leg, then I can calculate the hypotenuse. Okay, so now that we know that there is a relationship, what is that relationship? And the relationship is this. The hypotenuse is going to be equal to 2 times the shorter leg. So whatever the shorter leg is, and that's for the sake of what we're doing right now, we're going to give this a length of 1. So the hypotenuse would be 2 times that. So this would be a length of 2. The longer leg then is equal to the square root of 3 times the shorter. Okay, so the square root of 3 times the shorter. So if this is 1, then this will be the square root of 3 in length. And this is the values of this triangle that we'll use further when we get to trigonometry. So the main thing here is that if you have a shorter leg, the hypotenuse is twice the shorter leg, and the longer leg is radical 3 times the shorter leg. So if we sum that up in 2 equations, the hypotenuse, as I said, is twice the shorter leg. The longer leg is radical 3 times the shorter leg, both related to the shorter but not related to each other. And again, a little algebraic manipulation of this gives us a couple more equations. If I solve this for the shorter leg, that would be equal to the hypotenuse divided by 2. Or if I know the longer leg, the shorter leg is the longer leg divided by square root of 3. Okay, the hypotenuse and the longer leg are both related to the shorter leg but are not related to each other. Alright, so knowing those two relationships, we can then determine the length of any leg given a single leg. And there's 3 steps that you want to go through. So when you first come to a 30, 60, 90 triangle, the first thing you need to do is to determine which side is shorter, which side is longer, and which one is the hypotenuse. So you need to identify those so you know what you're working with and you know where to go. Once you've done that, then based upon what information you've been given, once you've been determined what information you've been given, then you decide which of the two equations can you solve. Let me go back to those real quick. So which one is going to solve? If I'm given the hypotenuse, there's no reason to use this equation because this equation doesn't even involve the hypotenuse, so I would use this. If I'm given the length of the longer leg, there's no reason to use this one, or it's impossible to use this one because there's nowhere to put that length. If I'm given the shorter, then I can actually use either one of these two because both of them involve the shorter. So it's important to understand which leg you're working with, what information you've been given, and then based upon that, that's going to determine which equation you start with. And then once you've established the length of one of those sides, you use the equation to determine your length, and then you can use the other equation then to find out or to determine the final length. Alright, so kind of a lot of information. Really, it comes down to, again, remembering these two equations, choosing the correct one to use based upon your information, and then solving those equations. So let me do a couple of examples for you. So in this example here, the first thing again that I want to do is to determine which is the shorter, which is the longer, which is the hypotenuse, and then go from there. So here's my 90-degree angle, so the letter F here is going to be my hypotenuse. And then here's my 60-degree angle, so opposite of here, this is going to be my longer leg length. And then here's my 30, so this is my shorter. So in order to determine these two variables, I need to decide which equation is the best to use. Now, I've been given the longer side. So the equation that I want to use is the one that has to do with the longer side. There's no way to use this equation with the number I'm given because there's nowhere to substitute it into the equation. So I'm going to use this equation and substitute the value that I'm given into the expression and then solve for the one that's missing. So I'm going to use the fact that I know that the longer leg is equal to the shorter leg, whatever it is, times the square root of 3. So my longer leg is 5, so I substitute that in, and that's going to be my shorter leg, which is in this case D, times the square root of 3. And now I'll solve for D. So in order to solve for D, I'm going to divide by the square root of 3 because that reduces to a 1. So I'm going to end up with 5 square root of 3. Now, as a rationalized answer, we need to rationalize this denominator, so we're going to multiply numerator and denominator by square root of 3. So the length of the shorter side is going to be 5 square root of 3 over 3. Okay? Now, in order to find out f, I need to determine, use the other equation. In other words, if I go back to the other equation, in order to figure out the hypotenuse, I need to multiply 2 times the shorter leg. And I just calculated what the shorter leg is, so now I can use this value. So the hypotenuse is 2 times the shorter leg, which in this case is 5 square root of 3 over 3. And then to multiply fractions, actually let me use the letter that they use here, hypotenuse here, this is f. So f then is going to be, again, we're just multiplying fractions, so numbers that are outside the radical can be multiplied with other numbers that are outside the radical. So I have 2 times 5 here, which is 10, and then the square root of 3 over 3. And so the length of f would be 10 square root of 3 over 3. So you can notice how I couldn't determine f directly. I had to figure out the shorter leg first and then take that value and figure out f, which is the hypotenuse. Okay? So again, look at the information, decide which equation is best to start with, simply solve the equation, and then work your way around to what you need to determine. Okay, in this example again, we recognize that this is a 60, so this must be a 30-degree angle here, so this is a 30, 60, 90. And again, I want to identify my parts first, so opposite the 90, this is my hypotenuse then. And then this is opposite the 30, so this is going to be my shorter side. And then this is opposite the 60, so this is my longer side. Okay, now I have to decide which equation to use. Well, I'm given the length of the longer side, so I need to use the equation that uses the longer side. And you remember our equation is that the longer side is equal to the shorter side times the square root of 3. So then I'll substitute in these values. So the longer side which they give me is 9 square root of 3. The shorter side here is x times the square root of 3. So I simply solve for x. So I'm going to divide by the square root of 3 because that is equal to 1. So if I divide by the square root of 3, that reduces that. So my shorter side, or my x value, is a 9. Now that I know what the shorter side is, I can use the other equation. The hypotenuse is equal to the shorter times 2, and substitute in the values. Here the hypotenuse is given the letter y. The shorter leg I just determined as 9 times 2, so here my y value is 18. Okay, so again, the arithmetic of it isn't too difficult. I think all we need to be able to do, again, we follow those 3 steps. In a 30, 60, 90, determine what the sides are, and then based upon what information you're given, choose which equation to use, and then solve for the missing variables. And again, there's only 2 properties here that we really need to remember. The longer side is the shorter side times square root of 3, and the hypotenuse is the shorter side times 2.